Hello and welcome to my part two on blockchain fundamentals. So before you take up the this video or go through this video, which is more on the code demo, I would strongly recommend that you go through this part one, which would set you up for what we are going to go over here, which is primarily the code demo. So if you have seen my earlier video, I think you have seen this code that I'm showing you here. So this is split into two parts. So one is the blockchain here class, and then the second part is a simple web application built on top of the Flex Python web application framework, and it has three RESTful APIs. So one is the mine block, excuse me. One is the main block, mine block, and then the second one is called the get chain. So the mine block technically creates a block through the proof of work and adds it to the chain, and then get chain returns the JSON object with the list of the blocks added to the chain. And then last but not the least is valid chain, goes over the entire blockchain and validates the hash, which technically validates the integrity of the blockchain itself. So it checks, the hash of the current block and the previous hash of the current block to the previous block. So it goes through all the all the blocks in the blockchain. So keep in mind that this is a private blockchain that I'm going to show you. This is not a distributed blockchain, but you can add the distributed feature to this. So I'll leave this up to you, so you can take this code and you can do whatever you'd like. So also this code is published on my GitHub repo. You can find me on the GitHub through this ID here, IT Guru Hasib. So I've also created a simple wiki page that you can take a look. I would strongly recommend. I've added what are the prerequisites that you need. You need to have Python, you need to have Anaconda, you need to install Flask, Pip, etc. So all of that goes in here, and I've also added what should be the Postman request for each REST API, and then also I have added the Postman collection itself. So if you go back here into the main repo, if I go back to, I guess, blockchain, yeah. So this repo is called the blockchain, and under that you would find a folder called Postman collection. So you can go and download this, and also you can clone this code from here. So that's GitHub for you. Now coming back to the code demo. So what we will do here is we'll run the Python web application, and we'll use Postman to make these three requests. So as you can see here, I have a block collection, Postman collection, to get a blockchain, to mine a block to the blockchain, and then to validate the blockchain. Okay, so here there are certain things that I haven't added to keep this demo simple. This blockchain is not persistent, so there's no database. So I'll leave this entirely up to you to add those missing pieces and make it more interesting. But I'm not going to do this here, but I think this sets you up for doing some interesting things. So please take this and go ahead and do whatever you'd like to do. Okay, so before I do this, so I'm just setting the proof of work here, mining difficulty to 4 leading zeros. I think if you have gone through my earlier video, I've talked about something called mining difficulty and the significance of leading zeros. So the more I have leading zeros, what I'm trying to do is I'm increasing the difficulty for the miner, and increasing the difficulty for the miner by reducing the number of options inside the hash pool to pick a valid hash. So that's what I'm doing. So if you look at the hash, it is 64 characters long. So here I'm saying that by adding this 4 leading zeros, out of the 64 character, the first 4 should be leading 4 zeros. If I add more, so it will be 6 leading zeros here. I added 2. So when I do this, the options get more narrowed down. Okay, so to begin with, we'll start with something pretty easy, and then we'll also change the number, and we'll come back and see how the mining works and how much time our postman request also takes. So I think we spoke about that. Let's get into the demo by firing this up. Let's stop this and start this again. Now let me open up my postman here. So what I will do is I'll fire up the get chain. So what it will do is it will try to get the uh, blockchain. If there are no blocks in the chain, it will add the first block, the genesis block. So you can see that it technically added the first block. Okay, now let's go and do something interesting, which is to mine a block. So when I run this postman request, so what will happen is the request will come through here, and it will execute the proof of work. And if this is successful, it will add a block to the blockchain. And then what we are doing here is we're returning the JSON response with the the block that is being mined. So that is what happening here. So let's go back and try that. So we are mining a block. It's taking some time. I think what I did was maybe I didn't save my mining difficulty, so that's why it's taking some time. Because here I changed it from 6 to 4, and I didn't change this number. Okay, so I think I did that wrong. So let's go back and fix this. So what it was doing was I had 4 zeros. It was checking for 6 zeros. So and then the program was failing. Okay. So let's do this, and let's run this again. Okay, now let's start with the chain, and now let's go back and mine a block. Yeah, you can see that I mined successfully a block, and it has got a nonce index. So this is my second block. Let's mine one more, one more, one more. So I can go on and on and on. So if I go back and look at my chain, as you can see, it's already increasing. I have like 7 blocks added to my blockchain, and you can see that I have a previous hash, which is the hash of this block, and then this block hangs on to this block by its previous hash, and so on and so forth. Now, the other thing that we would try is to increase the mining difficulty. So you notice that when I was mining the blocks, the blocks were getting mined so easily, within not even a second, right? Now I'm changing this to 6, so I'm increasing the difficulty to something, greater. So now let's stop this and start again. So since this is not a persistent blockchain, if I fire up a request, so I'll get a new chain, understandably. Now you can see that. Now if I try to mine a block, now you can see that it is taking now considerable time. If you compare our earlier request, which was like, going through pretty fast, now this took some time. Now if I mine my, another block, it should also take some more time. Yeah. Now if I mine the fourth block, it should also take some more time. So meanwhile this comes up, I just wanted to show you something also. I thought this is a very useful site to go and look at about mining difficulty and some statistics. So this is called the blockchain.com. So I like this site because you can go and pull up data related to blockchain, and specifically if you are like a Bitcoin user, I think you get a lot of data here. So if you look at like in specifically I think Bitcoin, how is the mining difficulty adjusted every week? So you can see that to begin with in 2009 the difficulty was something very less, and you can see that now I think until last year the mining difficulty was more. Now people have stopped mining blocks, the difficulty is also dropping, and you can see that it is now considerably picking up. So the mining difficulty is adjusted as you have more blocks, because you start using the valid hashes and the options getting narrowed down. So the more people mine, the difficulty also gets more increased. So I would recommend checking out this site. This is a very interesting site. It has some statistics, data, and all of that. And also one more thing I wanted to show you was like if you go and look at a block itself, for example, yeah, let's look at this block here. So you can see that it has this two properties called hash, previous hash. So for example, if I take this here, this is for I think Bitcoin, I guess this block. If I'm not wrong, yeah, this is a Bitcoin block. Yeah, this is for Bitcoin. So let's try to look at how many leading zeros it has in its hash. So I'm using JavaScript. So I love JavaScript. So just running this up. So you can see that they have increased from 18 to 19. So we started just playing with 6, and you could see that it was taking considerable time. Now I got this. Yeah. So imagine if you have more leading zeros, what would be the difficulty for mining? And that's why there is a lot of computational power that also goes into hashing. Before we wrap up this video, maybe one more thing I wanted to show you if I could. Yeah, so this is about Bitcoin. So you can explore this site. This is pretty interesting. So you can also see like any new blocks or transactions that is getting added into the network, that is basically pushed down here real time. I like this. So all of this is called the unconfirmed transaction, which will be added to the network at some point of time. But just to give you an idea, in the network there is this activity that is happening, and you can see that all of those blocks that are getting added, or anyone doing any transactions. For example, someone is doing a transaction for 76 Bitcoin or something like that. So all of that gets added, and also you can see the numbers here, but you don't know who is doing what, because you can see that it is all hashed, cryptographically hashed, and this is what it makes it anonymous. This is one of the intrinsic property of the blockchain itself. So I think you get the idea now. So as I said, take this code, run it through, and add things on top of that. I'm looking forward and excited to see what you can add on top of this. I hope you enjoyed this video, and I hope it gave you some insight, and it was informative for you. If you have any comments or feedback or questions, I would strongly encourage you to leave a comment at my YouTube channel, or you can also reach me through my GitHub. I would be more than happy to answer you. Yeah, thank you so much for watching this video. I will come back with another great video. Thank you once again. Bye bye.